so a quick review on that one is basically just showing the two triangles are congruent. We did a reflexive property, AC congruent to CA. Then the definition of parallelogram is that the opposite sides are parallel in step 3. And then step 4, that gave us the alternate interior angles marked in blue being congruent. Therefore, we have triangles congruent with by angle side angle. And if the triangles are congruent, then the corresponding sides are by CP, CTC. It ends up being the sides in the parallelogram. Well, any questions, thoughts on number 1? The main thing I thought of is that was basically the only new one. We've seen all the other stuff before. So it's a good review one. Okay, let's move on to number 2 then. Similar setup. So we're going to have parallelogram ABCB. Prove that in a parallelogram the diagonals bisect each other. So the goal is to say that these are going to be the diagonals, that the little parts are congruent, and therefore I guess we could have taken one more step and said, well, therefore they bisect each other. So I'm going to draw in the diagonals, and I'm going to call E the intersection point here of the diagonals. So let's set this up. So given this parallelogram with E the intersection, show that these parts, AE to CE is congruent and BE to VE. Those are the parts of the diagonal, so they would be bisected. Let's see. Now this one, before we start, we need to identify which triangle. It's again triangle proof. If we can show some triangles are congruent, then the sides we won't, these segments we won't be congruent. The question is which triangles, because now there's many triangles we could choose. So if we choose the same ones as last time, and let's say we prove those are congruent, well then we would only know that the entire length here, right, is congruent to this entire length. We then have to break it up into AE and EC with second addition. Which is possible, but it's going to take a lot longer. So I'm not going to choose those triangles. Instead, let's choose some of the smaller triangles. For example, if I choose that top and bottom small triangles, if I showed those were congruent, aren't these the ones that match up? And then these two. So it makes more sense. If I just show those small triangles are congruent, it will directly say this thing, what I want to prove. So I'm going to stick with those. You could have also chosen the left and right triangle in this one. I will stick with the two red triangles. Okay, so let's show those are congruent. I am going to start the same as the last proof, number 1. It's a parallelogram. I should mention this too. We can't use the other theorems, okay, unless the problem says. But we can always use a definition. So the definition is that there are parallel sides. I don't need both sets here. You can write it if you want. I only need BC parallel to AB. That is, again, this follow number 1, definition of parallelogram. Definition of parallelogram. And then same as number 1, the next step would be that we have alternate interior angles. And so I'm going to choose this one and this one. So that is what? Angle CBD, or if you like, you could call it CBE, same angle, congruent to angle ADB. Or you could also say ADE. And again, those are alternate interior angles theorem. one more angle. Well, I should say we're going to get one more angle and a side. For the next angle, you have a choice. Here's what I'm going to do. I'm just going to stick with the alternate interior along this. I'll choose this transversal this time, and these two are alternate interior. All right, so I'm going to choose those two. Before I write that down, if you would rather, though, you could take another step and do vertical angles, because the triangles are bow tied. Okay, so I'm going to keep this as step 3 and do it the other alternate interior. If you'd rather, though, you could have a step 4 and put vertical angles there. So I'm sticking with the double arc one here. So that's angle BCA or BCE, congruent to angle DAE, or I'll call it DAC. And that was still alternate interiors, still part of number 3. Okay, and again, if you'd rather, you could have done a vertical angle step. Now, we are going to need a segment. For any one of these up here, you need a segment to be congruent. There's nothing else we know that's given or with a parallelogram that we could use. So I'm going to allow us to use number 1. Now, normally I really should have added this. I should say we can use the theorem from number 1. Otherwise, you don't. I will be clear on a practice. I already have in the practice or a quiz or test which ones you are allowed to use. I'm going to use number 1. I'm going to draw from that. What number 1 said is opposite sides in a parallelogram are congruent. If I look at the big parallelogram, these are the opposite sides. I could have done the other two as well, but I don't need these. So I'm going to say that they are congruent, BC and AD. The reason that this is also new is just writing one of the properties. It was the property that says opposite sides are congruent. I'll put opposite sides of a parallelogram are congruent. Opposite sides are congruent. Okay, so again, I'll be very clear on practice or quiz if you're allowed to pull other theorems and use those. All right, finally, the triangles are congruent. We've got 2 angles and a side, and the side is again included. So it's angle, side, angle. If you had done vertical angles, instead it would have been angle, angle, side. You could, but we're trying to get the triangles congruent.